have to be careful about the statement of the problem because here's almost the same problem. Still the same function, y equals square root of x. X domain being from 0 to 4. But now I'm saying revolve this around the x-axis. Well, let's just completely change the problem because I look at this, say, okay, it looks like that. 0 to 4, I cut this off at 4. But now I revolve around the x-axis, and now it brings us back to looking like a bullet like we had before. But again, to use the cylindrical shell, I can use it in either case. I've used the cylindrical shell. My cut is parallel to the axis of rotation. That's a delta y. I see that right away. Other things that I see, that means my entire integral is going to be a dy. My limits need to be y, not x. I know x is from 0 to 4. That indicates to me that y is what? Well, 0, square root of 0 is 0. Square root of 4 is 2. So the limits are going to be 0 to 2. Again, I make that slice. I'm going to pull that out of there and unroll it. So it looks like this. And this distance right here that I have to worry about, well, that's now what we've referred to before as the h. And this side over here is the 2 pi r. And I need to determine what those things are. And I look at this and I say, well, this distance from here up to here, what's that? That's y. Okay. 2 pi y. That part's good. I have to watch the other part. Why do I have to watch it? Well, because I look at this and I say, well, what's that h? What's the height? Well, it's changing. Obviously, here it's smaller than this, here it's bigger. Okay, so I have to look at that and say, well, what is that height? Well, the distance all the way over to here is a distance of 4. And so the distance from here to here is then 4 minus x. Right? I'm sorry. Yeah, the distance all the way over there is 4. This distance right here is x. Therefore, the distance from here to whatever point we're getting to there is 4 minus whatever x is. And x is a moving target. So I have to do a little bit of work here and say, well, y squared is then equal to x. I need everything to be in terms of y. That means that that distance, that's what we refer to here as the height. Now the height is 4 minus y squared. And so, since I have that 4 minus y squared, I put that in here. Here I have the circumference. Here I have the height. Between the two of them, I can integrate this. I pull the 2 pi out. I've got the integral from 0 to 2 of 4y minus y cubed dy. I pulled the 2 pi out, I distributed the y. Again, the integral itself is not a particularly challenging integral. Raise the power by 1 and divide by it. Raise the power by 1 and divide by it. Input 2 and 0, and 0 is not going to give us anything, so I end up with 2 pi times. Put a 2 in there, it squares 4, and 16 over 2 is 8, minus, put a 2 in there and take the fourth power, 16 over 4, which is 4. 8 minus 4 is 4. I end up with 8 pi for that entire value, which, by the way, we did this by the other method previously, and we got a value of 8 pi when I did this in the preceding section. So, you can do it either way. Again, with these, we can have cases where, you know, this was just the line x equals 4, but it could have been that we had a slanted line there, just like we could have the slanted lines in the other ones, and that this, you could be taking some value here minus a value here in order to get what that height is. They both could be moving targets.